know if you can see my screen.
Yeah, we can see. Yeah.
Okay, thank you. Okay, so I'll just start with the basics of cellular. So just to let you know where cellular is being applied and where it can be used. So when you imagine a cellular router, you should imagine how your work phones with a normal SIM, right? So even a cellular router will have a NIM or an HPIC card that has a SIM inserted into it, and then it works exactly how your phone works. It assures a connectivity to your native to your nearest base station from the provider, and then has the normal 4G, 3G, or 5G connectivity based on the kind of card and SIM that you have. So this really helps you to enhance your WAN experience in your branch at remote locations for better user experience. And this is more so ever even more applicable now because in COVID, it's not easy to travel to sites and it's not easy to have physical connectivity to set up all that. So more and more customers are using that, especially in locations like ATMs or trucks that are mobile. So obviously, when it comes to anything mobile, we mostly use cellular connectivity. So like cargo ships, normal ships, even ambulances, trucks, all these are the applications where cellular routers are used to establish network connectivity. So this is where cellular is mostly used. So, I mean, just when you imagine a cellular router, just think of how your mobile operates. It's pretty much similar. And so I'll, uh, so there are a few cellular routers. So we have routers like ISA 4K, and then we have the ISA 1100s, and then we also have 800 routers, 2900, 3900. And all these routers have an HVIC or a NIM LTE card that is inserted into the router for it to act as a cellular router. There are few fixed platform routers like 887, 867. So they have cellular modem and card integrated into the router because these are fixed platforms. Everything except apart from these platforms and a few IR 1100s as well are fixed. Apart from that, everything will have a card like how you see on the top right of the screen. So this is how an LT card will look like. So it will be a card with the Sierra Wireless modem. So all our modems are from Sierra Wireless, and the Sierra Wireless modem will be fixed onto this card. And then you will also have a slot to insert the SIM on this particular card. And once you have the card in place and you've inserted the SIM, then you can go ahead and insert the card into the router, and then you can expect to see the cellular interface on your show IP interface 3. Also, these cellular cards will have some slots, like how you see in these two cards, to attach external antennas. Now, what does an antenna do? It basically amplifies your signal, right? So if you have, so cellular works on signal strength. So, when you go into low reception areas and you cannot make a proper voice call, or you're not able to hear the other person, that's because the signal strength or the coverage in that particular area is bad. And to amplify that for a cellular router, you can either move that router to a better location, but most of the times it's not possible to simply move the router to an area which has better reception because of the restrictions. So in that case, what we do is we attach an external antenna. So Cisco manufactures antennas as well. So they help you to amplify the signal strength and get better signal strength for the cellular router so that we can have seamless cellular connectivity. Now, since it's a cellular card, obviously it will have a modem built on it, and these modems are manufactured by Sierra Wireless. And so, how do you know which card has which modem? There are plenty of modems like 7430, 7300 series, that is 7700 series. So how do you know which modem is on which card? And that is essential because only after you look at the modem, you will get to know which modem firmware is being used for the cellular card. So when you have a cellular setup, you have the normal router iOS, and then you have the cellular firmware. So how do you know which firmware to use? The firmware totally depends on the Sierra Wireless modem that is being used for that particular card. So we need to identify which modem it is to find out which is the firmware version and get to know, okay, is this firmware version okay for this particular IS? Do I need to upgrade the firmware version? So we'll first see how we recognize what modem it is. So first, thing is physical inspection. So once you take out the card, you will see the modem on the card as well, and it will the modem number will be written on top of that. That mostly is not very feasible because customer is not at site, or uh, there is somebody on site who's not like knowledgeable enough to even take a look at it. So in that case, it's not really feasible, but that is one of the options. The second option is to run a show diet on the like your normal router console, and then you can see the modem version there. So if you see this, it will tell you what is the modem number, and the most usable form to actually see it is using show inventory. So all you do is just do a show inventory right below where your cellular card is. You'll see the modem slot here. So this is my lab setup, and if I do a show inventory here, so this is my cellular card, EH EH4G LTE, and right below it, I can see what modem is installed on top of it. So it is a 7700 router. So once I know that it's a 7700 router, it's easy for me to know, okay, what firmware should be used for it and what are the limitations for this firmware. Do I need to upgrade? So that is one way to identify. The most usable form is to use this. Or you can also do a show controller. Once you do a show controller, you'll also be able to see the modem that has been installed. But the most easiest way, according to me, is to just do a show inventory, and you'll see what modem is in use, and then you can proceed according to that. So this is how we recognize which modem is used on that particular LT card. Okay, so cellular, I'll just talk about some features about cellular. So cellular modems support AT commands. AT is nothing but attention commands. And what it does is like, so the modem that you have, most of the times you cannot run direct commands on the modem. You have to reverse telnet into the modem. There are some CLIs that allow you to run AT commands directly on the CLI itself, like where we run the show commands. We can run AT commands there, but most of the routers do not support that. You have to reverse telnet into the modem. How do you reverse telnet? You make a loopback interface, and then you use that loopback interface to go into the line of the modem, which is most of the times 2003. But then you can obviously verify that using show line. So if you do a show line, you will see that these two lines are used for your cellular, because you see cellular 010 and 011 at the end, right? So which line numbers are in use? 19 and 20. So if I want to reverse telnet to this particular line, it'll be telnet, then my loopback IP address, and then these ports. So if I want to reverse telnet into 010, I'll put 2019. If I want to telnet into 011, I'll put 2020. So what the AT command does, AT commands are basically attention commands that are ran on the modem. So it will give you direct outputs from the modem, because when we run commands on the CLI, it gives this command from the iOS perspective. If you want to have like raw outputs from the modem, that is when AT commands are in use. They're not used very often, but in some cases where you will need advanced troubleshooting, which we'll talk about later, is when the AT commands come into use. Cellular routers support your normal IP data frames. Slip mode is configured in iOS devices. It was configured. It is an essential part of configuration when you configure in cellular devices in iOS. So you do an encapsulation slip under the interface. This is also an iOS device. This is a 2900. So if you see, I do need to have encapsulation slip here. And this is a mandatory configuration in iOS devices. It's not that my data frames will convert into SLIP. I will still use IP frames, but it's just a legacy configuration that's needed for iOS. In iOS XE, you do not need to configure encapsulation. You just don't need to configure the encapsulation at all. So that is the data frame side. And the cellular modem uses a chat script to initiate the call. So using the chat script is what the modem tries to dial into the router, dial into your provider. So this is how chat script looks like. So the chat script LT is just a keyword that I've given. This is the AT command that is uses to dial to the provider, which is 80 exclamation call. The timeout is 60 seconds, like it'll wait for 60 seconds to dial in. And if it gets an okay from the provider is when your connectivity will be established. And then the rest of the process continues. So you don't need to worry about configuring chat scripts because we have fixed chat scripts for all the different kinds of technologies like 3G, 4G, and for the iOS XE devices, you do not need to configure the chat script. It's embedded into the modem itself. Only for iOS, you need to configure the chat script like I have in Shoran. In iOS XE, you do not need to configure it. It's already embedded. Even when you do a Shoran, you will not be able to see the chat script in the Shoran. Okay, and how do you clear the call when it's going on? Like say I have a cellular connection up and I want to clear that connection. I want to shut it down. So you can either clear the interface, you can clear that particular round, you can shut down. You can also give something called dialer idle timeout. So under the cellular configuration, you have dialer idle timeout 0. I've given at 0 because I don't want it to be timed out. But say if you want to time it out at 60 seconds, you can put 60 here or 30, depending on what kind of connectivity your like your customer wants. You can have the dialer idle timeout set. So basically, if the cellular connectivity is not in use for 60 seconds, it will use this command if you've given it, if you've configured it for 60, and then it'll disconnect the line. It will bring it down. And the next time so cellular works on interesting traffic. It will only come up if it sees that, okay, there is some traffic destined out of my interface. Only then does the cellular interface come up. Otherwise, it will go down. If there is no traffic running on a cellular line, it will lose the IP that it has negotiated from the provider and it will go down. And the 80 commands cannot be run when your call is in progress. And you don't then it's CHAP authentication is used in 4G mostly. 3G does not need CHAP authentication, and CHAP authentication basically is configured in your profiles. So if you I'll let you know what the profile is shortly. So all cellular connections will have a profile, and when I say profile, I mean the APN name. So the access point name and these fields, the access point name, what kind of authentication I have to use, the username and the password is provided by the ISP. It's very ISP specific. It's sometimes feasible to just look online. So if I know my provider is Airtel, I'll just search for Airtel APN names and it will give me some generic APN names like, okay, this is what I got from Google. I see that the APN name for Airtel is generally airtelgprs.com. You might have seen your phone earlier that sometimes when you try to fiddle with the cellular connectivity, you would see that this is the APN that's configured on your cell phone as well. And so the APN name, what authentication is it using, none or PAP or CHAP, and the username, password, all this has to be specified by the providers when they give you a cellular connectivity so that you can configure the same on your router. So this is what I've configured. I've configured airtelgprs.com because the SIM in this router is an Airtel router, is an Airtel SIM, and they do not have any authentication specified. So I've kept the authentication to none. But then you could have authentication like PAP or CHAP, but this needs to be made certain by the provider themselves that what kind of authentication do they want for the cellular. And for cellular, you will see a lot of cases where the customer comes in and they're like, okay, I have set speed on my cellular. I have set like say 10 Mbps speed on my cellular, but I do not see that. And you'll ask, how have you set the speed? And they'll say, okay, I have gone into the line configuration and I've set the RxTX speed, or I've gone into the interface configuration and I've set the speed, but it is not effective at all. You cannot set the transmission or the receiving speed for cellular connectivity. Even if you have the CLI that allows you to set the speed, the cellular, it will never come into effect. The speed solely depends upon the bandwidth of the link and what kind of signal strength you're getting from the provider. It will not, whatever speed you enter into the CLI is not going to take effect. So the bandwidth, the peak rates and everything, they will never come into effect. So I'll just show you how a basic cellular configuration looks like, and then it'll make more sense probably. So this is the configuration for an iOS. So the first line is the chat script. So the chat script is what makes the cellular dial a call towards your provider. So if you see here, chat script is the keyword, then LT is a variable that I have defined. This is what I'm naming my chat script. It can vary according to you. So LT, it doesn't matter if you change it. Then AT call, this format cannot be changed. The double quotes, the spacing between that, it has to be exactly the same. The only thing you can change in the first line is the keyword LT, you variable LT, you can change it to anything that you want. But apart from that, everything in this syntax should remain the same. So AT call is when it asks the modem to establish a call. You are setting the timeout period. You can set it to 20, 30, 60 seconds, whatever. And OK is basically the response I'm expecting from the ISP. So the ISP is like, OK, I'm OK for you to set up this call. So the moment I get an OK is when the chat script is like, OK, the connection can be established and we can go ahead and do the rest of the connectivity process. The chat script is the command that is used to establish a call towards your provider. Once that is done, we'll come to the cellular interface configuration. So you go into the interface and then you configure IP address negotiated. Very few times do you actually get a static IP from the ISP. Otherwise, 99% of the times it'll always be IP address negotiated. What this does is that it will negotiate how you have IP address DHCP. So it will just negotiate an IP address from your ISP. Encapsulation slip, as I talked earlier, is needed for iOS as it's some sort of legacy configuration. Dialer in band is just to associate a cellular interface to dialer. And we set the dialer idle timeout to 0 or 30 or 60, depending on what kind of connectivity we want. Now, this is where the chat script, so you have configured a chat script, fine. But where are you calling this chat script? You call this chat script in two places. One in the interface, and second is the associated line width for that interface. So dialer string LT is, sorry. So dialer string LT is where we call this particular chat script. So this is where I was saying the variable you can change, but whatever variable you mention for the chat script like LT, you have to make sure you call the same chat script in your interface as well as line. So dialer string LT, dialer group 1, it's again binding your cellular to a dialer interface. Then you come to the line configuration, you set the timeout to 0. Basically, I don't want my connection to timeout. And script dialer LT, again, I'm calling the chat script here. This is the command to call the chat script under the line. Then modem in out, I'm facilitating in like both bidirectional traffic for my modem. This is not a compulsory command. You can ignore that if you want, but it's just one of the best practices, and no exec. Now I have my chat script configured, I have my interface configured, and I have my line configured. Now, since that is up, I need to provide a route out of my cellular interface. So you will specify a route that is going out of your cellular interface. And this is a very important line, which is dialer list 1 protocol IP permit. So you see a lot of times where the customer has everything in place, but then the traffic is still not passing through. That's because you have cellular connectivity works on dialers, and you have bounded to a dialer in your configuration, but have you allowed traffic on that particular router, on that particular dialer? So this is where we do it. We specify a dialer list 1, which is associated to group 1, and then a protocol, then the protocol is IP, and then permit means it's permitting everything. So this line is very important if you want to permit traffic on your dialer, which you should. And if there is some sort of config issue, sometimes the customer is missing this particular line because they're not aware of it. So you can go ahead and configure this. So we configure the chat script, we configure the cellular, the line, the route out of your cellular, and the dialer list to allow all traffic. It basically acts as an IP any access list. You can also specify certain subnets on this dialer list, or however you want to do it. You can permit everything, or you can specify a particular subnet. The last bit is the APN configuration that we talked about. This is the APN. And the last line is actually the first thing you will configure when you get a router. And this is same for iOS and iOS XE. So what we're doing is, okay, I know that I have a cellular connectivity and this is the interface I want to configure it for. So cellular 000. LT is the type of technology I'm using. This is not the chat script. This is the technology that I'm using. So it can be GSM, it can be CDMA, but since we're using 4G, we'll put LT here. I'm creating an A profile. So this is the profile that I'm creating, profile one. So profile create one. Test.com is the APN name. This is provided by the ISP. So the APN name, which is airtelgprs.com. And then what kind of authentication are you using? So if you are not using anything, you can put none here and stop this command. If you're using CHAP or PAP, specify what kind of authentication is in use. This will also be mentioned by the ISP, and then the username and the password, which is provided by the ISP. So once you configure this, you will see all this field being populated in your profile. You can check that using show cellular 010 profile. So profile is the first thing you set up, and then you go about and configure the rest of the configuration that I've shown earlier. So this is the configuration for iOS. For iOS XE, it's much more simpler because you only need to configure the interface. So IP address negotiated, idle timeout. Remember that you do not need to configure the chat script or the line. So the chat script here is not needed, and the line configuration is also not needed, except that everything is needed and encapsulation is also not needed. So interface, IP address negotiation, dialer in-band, idle timeout, dialer group one, you specify a route through cellular, and then dialer list one protocol IP permit. That is it. The configuration for iOS XE is much more simpler. So I told you about the chat scripts that we use in iOS. So basically, we have fixed chat scripts for different kinds of connectivities. For CDMA, this is the chat script, GSM, HSPA, and 4G. So this depends on what kind of card you're using. Mostly now we do not get any cases on GSM or CDMA or HSPA. It's always 4G. So, and most of the time it's iOS XE, so you don't even need to configure the chat script. But if you do get a different connectivity where you are using GSM or HSPA, you can refer this and get the chat script from here. And then how we configured it for LT here, you can just configure it for whatever technology you're currently using. So that is where you refer the chat scripts. Okay. Okay, I'll just show you few things on basically this is a cellular router. So how do we see that which card is in use and which modem, as we talked about earlier? Just do a show inventory. You see which card is being used, ESWIC 4G LTE. Generally, the name will also have a proper description, like how you have for every other thing in show inventory. That this is A means North America. Basically, it's a card that's used for America. And so you'll have different cards like EHWIC 4G LTV. When it says V, those cards are used for Verizon. So you'll have different sort of cards for different sorts of customers, and that will depend on what provider they used or where they're based on. That we can check based on like case to case basis. And you will find that in the data sheet, okay, where is this card applicable for? And then once you know the card that you're using, you can see what modem is in use. And if you know the modem, the reason why I stress on the modem is because you need to verify, like how you do a show version for iOS, how do you do a show version for your cellular? So what you do is you do a show cellular 010 hardware, or instead of hardware, just give all, because all gives like all the information on the cellular. So this is the line that tells you what version is currently in use. So right now the version is 35292AP, which is the latest firmware for MC7700, and you will find this on CCO. I'll give you another link where you can know what firmware. So this is a link. I'll be sharing the link with you later. So this will tell you if 7700 is your modem type, which is the firmware version, which is the latest. And again, 7750, 73, these are just the different kind of modems that you can see. And then the firmware version, which is the latest for them, will be mentioned in this list. And where do you get the firmware version? You can just go to the cco.com, just search for your particular modem or HVIC card or router, and then under that you'll find cellular modem firmware, and then you can download the same. So that is how you download the firmware, and this is how you check if you have the latest firmware or not. So when does the firmware come in picture? So the moment in cellular cases when I'll actually doubt that, okay, it's the firmware that's causing the problem, is when I probably see my modem itself flapping in show logs, or I see my cellular interface going up or down, or my cellular is down despite everything I do. So that is when, because cellular in itself will always be up. So if you look at it now, if I do a show IP interface brief, you'll see that my cellular has no IP at the moment, because SIM card that we have in our lab in the router at the moment is not provisioned, that means it's not an active SIM. So Callo did not have an active SIM, so we did not get an IP, even though we have all the configuration in place. But the interface, if you see, it'll always be in up. So cellular, if you do a show in cellular 010, you'll see that the cellular interface will, even though it does not get an IP, it's not functional, but it will be in up mode, but it is spoofing, which means even though it shows that it's logically up, it's in spoofing mode, it's not really forwarding traffic. So the cellular interface tends to be always up if you have all the configuration in place. So, and if it's down, even after you have everything configured, is when I'll be like, okay, maybe something is wrong with my modem if the firmware is not upgraded, or if there is a hardware failure with my modem, or if the chassis is not detecting the card properly. So that is when I will look. So my ideal state for my cellular, when everything is configured fine, even if I do not have an IP, it should be that the cellular should be in up spoofing mode. So that is that. And I'll just show you the configuration again. So the same things that we talked, since this is an iOS XE box, you'll have all the encapsulation commands. You call the chat script, and you'll have the chat script configured. Just to know how we configure the line, which line do you configure, just do a show line first. So once you do a show line, you'll see which line is associated to cellular 010. So once you see that it's 010, the line which is 010, so you will, line. So I will configure line 010 for my cellular. I'll configure the chat script modem in out. And again, for iOS XE, this is not needed. It's only for iOS. For iOS XE, you do not need to configure the line. The line will be used, but it's just that we don't need to configure anything. So this is just the configuration part. What else? I'll just show you like some other fields on this output, because this is the output that helps you diagnose most of the things in the router, in the cellular connectivity. So this line tells you what firmware is being used. I'll just identify which are the ones that are needed for troubleshooting. Then this will tell you which is the modem that we are using, which you can also see from your show inventory. Then this will give you your IMSI, NI, and EI number. This is exactly how you work on your phone. This is your hardware identity, and this is your subscriber identity, which is the SIM. If it's a valid SIM, it will have an IMSI number. If it's a valid modem, valid cellular card, it will have a valid IMEI number. It's just how it's on your phone. So that is the thing that we check under the hardware information. So the first section is hardware information. The second section is profile, where we configure the APN, the username, and the password. So we check that under the profile. And again, if your profile 1 is up, you would see the same under the data connection information, where instead of inactive, this would be active. And you would see the IP that we've got from the ISP. Once you get an IP, you'll see it in show IP interface brief, show interface cellular 00. And then you'll also see it here and under the profile as well. Okay, and the next part is the network information. Now this is where I know that the SIM. So how do I know? How did I know that, okay, I have a SIM in my router, but that SIM is not proper. So how did I even get to know that? So I'll just scroll down this particular output, and what I see is that if I check my SIM status, it's okay. So which means that I do have a SIM in my router. So under this, you will actually get to know if you have, under the modem security information, you'll get to know if you have a SIM inserted in your card or not. If the SIM status is okay, that means the SIM is inserted properly. Now, if I have the SIM inserted, I want to know what is the thing that is stopping me from getting the connectivity or the proper IP address from the ISP. So the first thing is that we will check what is the signal strength. And how do we check the signal strength? We come to the radio information. So radio power mode should be always online. If your radio power mode is not online, if it is in low power mode, that means that there is a problem with the modem. Again, you will check the modem firmware, or you will check the IS version, or you will go ahead and replace the modem. So it should always be online. The current band is not negotiated yet because this is where you check the signal strength. So the RSSI should be between 60 to 90 for optimal usage. So 60 to 90 is good signal strength. So minus 60 to minus 90 is when your signal strength is very good. Anything below minus 60, so from 0 to minus 60 is excellent signal strength. Minus 60 to minus 60 is minus 60 to minus 90 is good signal strength. Above minus 90 is when you start seeing disconnectivity issues, or you'll see that the interface is not negotiating an IP address, or in our case where it's minus 128, which is as good as getting no signal from the ISP or the SIM card not being provisioned, is when we see minus 128. So once you see minus 128, it is expected to see in the network information that you have no service on the SIM. So in network information, what are the two fields that are the most important? The first one here, which is the current service status, this should be normal. If it's not normal, it will be no service, which means that either your SIM is not provisioned by the ISP, it's not an active SIM, or your RSSI, which is your signal strength, is bad, due to which you're getting no service here. And also your PS state. The second thing that you check is PS state. So this will tell you if your SIM is attached to the network or not. If it's not attached, which means that you have no service or your signal strength is bad. So all these things are very tied to each other. So all these parameters have to be in sync for the cellular connectivity to be up. So your current service status should be normal service. Then your packet switch status should be attached, and your RSSI should be below minus 90. So anything from 0 to minus 90. Now, if my RSSI is good, say if my RSSI was say minus 60, which means it's a good signal strength, and I still see that I have no service and not attached, that means I would go to my ISP and I would ask them that, okay, I am getting the signal strength. Is the SIM provisioned or not? And that is when the ISP will check if there's a problem with the SIM, or if there's problem with their settings, whether or not sending the IP or the service for that particular SIM. So this has to be checked from the ISP end. Now, if my signal strength is bad, what can I do? Again, as I talked earlier, so this cards, the NIM or the HV card will have slots to attach external antennas. You can either move the router to a better reception area, and if it's not feasible, which it is not in most of the cases, in that cases, I will attach an external antenna that will amplify the signal and help me get better signal strength. So that is how I troubleshoot issues with low signal strength, or if I don't see the IP on my cellular, when I know that, okay, I have a SIM inserted and my config is fine, but I do not see an IP being negotiated on my interface. So these are the things that we will check. Now, there are times when the customer will also be using the GPS feature. So you can enable it under the controller, and you will see the latitude, longitude, and all the GPS information here. Sometimes they use it for SMS. You rarely will you see this, but you will see the number of SMSs received and all that information here. So this is everything that you will see under show cellular 010 all. So the hardware information, the profile, whether it's active or inactive, what IP has been negotiated, what kind of service are you getting, what is the signal strength, and then the SIM status, if it's okay or not. Okay, so this is, I'll also show you how the controller looks like. Okay, so this is the show controller cellular 010 output. Here again, it'll tell you which interface, which card is being used, if the modem is being recognized or not. So the modem is recognized as valid. What is the manufacturer ID? Then you'll get to know which modem it is. So one of the places where I mentioned earlier where you can check what is the modem, you can also check under controller, right? So this is where you see this. This is the modem uplink and downlink speed, and this output actually is pretty huge, but these are the few things that are for use to us, where if you see the modem is actually, so there are times when the modem goes faulty, and here it will say that the modem is not recognized or the modem is invalid. This is also one of the ways that you will see, okay, if the modem is invalid, I will first check if the firmware is fine or not. If the firmware is not fine, I'll do a firmware upgrade. And if the firmware is okay, then I will go ahead and see if it could be a hardware problem with the modem. The rest of this output is pretty huge, and most of it is never used for normal troubleshooting. So yeah, not much to look here. Those are the few things that we check in controller. So I'll just take you through the different kinds of scenarios, the different types of, okay, so what are the debug commands that we can use for particular cellular connectivity? So debug chat. So when you do a debug chat and your router is trying to establish a connectivity, you will see that the chat script is being dialed out and you are getting a response, or if it's being timed out. So that is what you will see in debug chat. Debug dialer and debug modem will give you basic debugs about if the dialer is being connected or not, or if it's the modem is dialing out or not. So those are the few debugs that you can run. In show run, and show commands would be show run, your show interface, where you see if cellular is in up mode or if it's down, or the controller as we saw now, and the show cellular all output, which is the most important output to check everything. So these are the debug and the show commands that are in cellular. It's pretty simple. And I'll take you through the few issues that are commonly seen. So the first symptom is when you see that your modem is not attached. So it's exactly what we talked about here, where we see that our modem is not attached. So in that case, when it's attached to the network, this is how it looks like. The packet service, the third field that you see here, it is HSPA or attached, or in our router, it depends on router to router. It will always be named slightly different, but it will have the packet switched keyword, so you can look for that. And packet switch should be attached if it's proper and normal service. If it's not normal, then you will see it as inactive or not attached, how we're seeing right now. So in that scenario, what do we do? So we again check the antenna connection to check if the RSSI can get better. We can check the network coverage. So one way to see if your signal strength is fluctuating is to do a show cellular 010 radio. Okay, so this will just like how you use the show process CPU command to check if the CPU levels are fluctuating. This will give you a 60-second ratio, sorry, a 60-second graph, a 60-minute graph, and a 72-hour graph. This will tell you. So there are times when, say, when you join the call, you will see that, okay, my RSSI is 70, but the customer is like, no, but I lost my IP sometime in the last 1 hour or yesterday. So you will come for this graph and you will see that, okay, maybe it's okay in 60 seconds and maybe it's okay for the last minute, But in the last 72-hour graph, you will see that it fluctuated. There was a spike, and because of the spike, because of the signal strength going back, that could be one of the reasons as to why your IP would have been lost. So this is where you check the signal strength history for the router. So you just check the network coverage using that command. You also check if your modem is in the online state, as I mentioned. So in show cellular hardware, you will want to see your modem is in online state. If it's in something called low power mode, you will check the status to see if the modem is working fine or not. You'll check the firmware, and if it's not the firmware, it'll be a hardware issue with the modem. If the modem is in low power state, otherwise, if it's in online state, it's fine. You'll also check the presence of the SIM, how we checked right now, where the SIM status is okay. If the SIM is not there, you would see the second output where the SIM status would be removed. And then you will also check the IMSI number, how we checked in the output a while back. So this will tell you if it's a valid SIM or not, because every SIM will have an identification number, which is your IMSI number. So this should always be populated if you have a valid SIM. So these are the few things to check if you have issues when you see that your modem is not attached. Now, what do you do if you see that your cellular service is fine, your modem is attached, you have an IP, but your pings are still failing? If you have an IP, but your pings are still failing, or you can see that if, say, just forget about even the IP, but you see that everything is fine, your RSSI is fine, your SIM service is okay, you have normal service, it is attached, everything is fine there, but you do not have an IP. And also, obviously, since you don't have an IP, you can't even ping. In that case, we will verify the APN profile that we've configured to see if that is correct. You can get a verification from your ISP as well. Check if there is any subscription issue. That means that you can check with your provider to see if have to SIM is supposed to work with. And in the network, in the cellular output, you can see if it's in service or not. And then again, you can contact the ISP to verify any account provisioning. So this is what you check if everything is okay from your router and you see that everything is attached and everything is working fine, but you're not getting an IP, is when we will check these few things and we will get in. And then we will check our configuration as well. So you check the chat script, you check the interface configuration, the line configuration, and that is all to be checked when we are checking a normal cellular connectivity. This is a very basic flow chart to check if your SIM, like just to how to troubleshoot basic SIM issues or cellular issues. So you can look at this later, but this is just what we've talked about right now. It's just in a flowchart format. Okay, so see, as I told you, the cellular interface should always be up. But what do you do when you see logging messages like the modem is going down and up? So the log message will look like what you see on the screen, where you see the modem going down. So in that scenario, where you see the modem is now completely down, or it is going up and down completely, and then you see modem reset logs as well. In that case, you can expect that maybe the modem is crashing. And in those scenarios, what we do is we collect a crash dump. How we collect crash infos or crash files for CPU and router? So we will collect something called crash dump for the modem itself. And the command is test cellular host 0. 0 will be 010 or 000, depending on what interface you're using, modem crash dump. And then you write it onto the flash. You enable this, then you wait for the crash to happen. And once you see that the crash has happened, you can check that under the crash, this particular command. Once you see that the crash has happened, you will see that it will show that, okay, I have one crash dump located, and then you can get the code dump from the flash and then export it and then pass it on to the BU. We don't have a tool to analyze the modem crash dumps. We generally go to the BU to analyze crash dumps, but that only happens when you are seeing modem crashes happening. So you will see the modem going up and down frequently, or the modem is resetting. That is when we collect the crash dumps. Now we come to the DM log. The most of the issues where you have checked everything, where you've checked the signal strength, the configuration, and the ISP is also saying, okay, we have everything provisioned from my end, and it's still not working fine. In such scenarios, what we do is we collect something called DM logging. So the DM log tells us about all the communication that happens between the modem and your base station. So again, so when I'm not getting an IP on my cellular interface and the ISP is also like, okay, everything is fine on my end. So what the DM log helps us to isolate is that it will see those log messages that we do not see on CLI. So it will tell us, or debugs as well. So it will tell you, okay, my router is sending out a packet called attach request. So basically our modem sends out packets called attach accept, and from the other side, the ISP is supposed to send packets like attach accept to establish the connectivity, or if it does not, it will send you packets like attach reject. And there are many other packets as well in the DM logs that are captured, like PDN connectivity log, where you see this PDN just means your session connectivity or rejects coming from the ISP. So the DM logs help us to get a clearer picture as to which side. Is it the modem which is sending the disconnect or the reset, or the ISP that is sending the disconnect or the reset? And we have, so how do we collect it? We go under the controller cellular, and then we give the command LT modem DM log enable, and then you can store it either to your FTP. If you do not give the storage command, it will just be stored onto your flash, the router's flash. The moment you enable this DM log is when you'll see that the DM log has been enabled, and then you will see that it's being stored onto your router's flash. Once the DM log has been enabled, we would want the issue to happen again so that it captures the particular set of logs. And if it is something where the cellular is not coming up, it is consistently not getting an IP address, so we try to force the communication to happen. So after the cellular, we have enabled the DM log, we switch on and we turn on and turn off the LTE radio. That is done using the command LTE radio on or off under the controller, or we do a shut no shut of the interface. We try to ping through the cellular interface and all these things just to trigger some sort of connectivity and to make sure that we get enough logs on the DM logs. Once we have the DM logs, we just upload it to the tool that we have, epdm.cisco.com, and that will decode the file, and it will also give you basic error. It will pass for the basic error or the attached messages, and I'll tell you if there's a problem with that. If not, you will still have the decoded text file. And if you're not able to understand, we can always take the BU's help to understand the DM logs as well. Because we only know of, like at the moment, we know only a very little part of the DM log messages. We only know about attached requests and PDN connectivity messages, but it's a very huge file. There is so much information in it. So even if CAC is not able to identify it, we can get BU help to look at it. So DM logging is mostly used in all cases where you see everything is fine in configuration, everything is attaching, it's an attached state, the service is okay, the RSSI is okay, and then the ISP is also like, okay, I've provisioned this SIM, I think everything is fine. That is when we take DM logs to actually find out where the fault lies. So that is about DM logging. I think that's pretty much it. The reason is that I actually wanted to show you a working lab, but then in our lab, we do not have a provision SIM at the moment. So it was not possible for me to get a lab to show you an IP being assigned to the interface. But yeah, I hope you got like a basic picture about how it works. That is it from my end. If you have any questions, please do let me know.
Hi, Soumya. Thanks for the session.
Hello.
So I actually had not exactly a doubt related to this, what you just explained, but like I had one of my cases where the customer is actually on their slot 0, they have a big card, and
Mm-hmm.
also they have the same Sierra module on module
Mm-hmm.
0, and
Mm-hmm.
that is working for cellular 000. But
Okay.
the issue is that they're seeing some alerts for cellular 003, even though cellular
Okay.
003 does not exist even in show IP interface brief. But if you do
Okay.
a show interface, cellular
Mm-hmm.
003, we are
Mm-hmm.
able to see an output. It doesn't say the interface does not exist. And the output is exactly similar to what is coming for 000. So is it like expected behavior or like
No, this is definitely not expected behavior. If you have so basically your card is in slot 00, right?
correct? Yeah.
Okay, and the active interface is 000, but you are seeing logs for 003. In show IP interface brief, do you see cellular 003?
No, only the 000, the active interface. That's it.
Okay, and when we try to configure 003, we're not able to do that as well.
Yeah, yeah. So only in SNMP alerts and the output that I
Mm-hmm.
just said, show interface is where we see.
Mm-hmm. No, this is mostly a buggy behavior. It's not likely that there's no interface that exists, but you still see alarms for that. So, and that is not possible. Also, because the card is in 00 and you already have the slot up and running, so it should not even have any connectivity to because you have just one modem, right? So one modem will only work for one line. It cannot work for multiple lines at the same time.
Yeah, yeah, got it. So this is iOS, so maybe I should be looking towards a bug, I guess, right?
Yes, yes. Try to see it if you can get it into the lab. There is some chances you might not be able to reproduce this in lab. But try to see if you can get this in lab. If not, then just try to contact the BU. This is definitely a buggy behavior. This is
Okay.
just SNMP traps, but then you also see it in the router CLI, right? If it was just the SNMP traps, we could have
Hmm.
probably located it to be of issue with SNMP traps. But if you see it in the configuration, we can get the BU to take a look at it. It's definitely buggy behavior.
Okay, got it. Thanks. I'll look into it.
Welcome.
Hi, Soumya.
Hello.
I do have a question.
Mm-hmm.
Sometimes when we see the output for show cellular 00 all,
Mm-hmm.
hardware information is not even populated, like it is completely
Mm-hmm.
blank.
Mm-hmm. Mm-hmm.
So what does that indicate?
So if you don't see these fields being populated here, that means there is a loss of connectivity between your iOS and the modem. So there is a bug which is pretty old. It is on 15.5.3 and it was fixed post that, where the modem used to lose connectivity on like on your the modem used to lose connectivity with the iOS, and for that we used to do an upgrade. But if you are already using an iOS version that is above that, then it means that there is an issue with the card itself or the chassis, and then we follow the normal troubleshooting methods. You'll insert that into a different slot and see if it is readable there. If that is there, then it's not a problem with the card, then it's a problem with the chassis. And if the card is unreadable in multiple slots, that means that's a problem with the card. If you don't see the fields being populated here, which means there is a loss of communication. And also, like, since you're not able to see it here, and if your modem is still up, and since you can't check this particular field, you'll probably not be able to see what firmware version are you using. But as a precautionary method, if your modem is still up, you can still try to do an upgrade with the latest firmware version and see if that resolves the issue. If it's a problem with the firmware, you can do that as well.
Okay, thank you.
Welcome. There's any other questions? Or anything that you've seen in your past cases that you probably have a doubt about?
So Soumya, I have a case where I have to upgrade the LT module.
Mhm.
So in LT module, why do we need to create a separate directory? Actually, that's what I just
That is
want.
that is only there for 7430, right? So if I think it's you're talking about the MC7430 probably. The all other firmwares are upgraded directly. You just put it into the flash and then you use the microcode reload firmware command. But only for 7430, it is set like a set of configuration where you have two files, the CWE file and the NBU files. You have to put it into a directory and then run the code for that particular directory. That's just how the modem is built. But that is only there for one modem. It is not there for the other modems. It's only for 7430, if I'm not wrong.
7340.
Sorry, yeah, 7340. Sorry.
Yeah. So I had a case where I was struggling with creating directory and all because this is new for me. I recently start picking the
I get it.
AL.
If you check the release notes, you will find it listed there. So if you would actually check the release notes for 7340 or any modem for that reason, because everything is consolidated into one release notes, you would find the step-by-step upgrade process for that particular modem as well.
Yeah, so I tried directly on customer network. Fortunately, it works. So I thought let's clear this because if this is applied on all the devices, then it will be problematic.
It's only there for 7300 seats, either 73 or 74. I'll have to check. But since you already mentioned 73, it's only for one series of modems. For everything
73
else,
only, yeah.
yeah. For everything else, it's like one direct firmware that you put onto the router, and then it just works seamlessly.
Yeah. And most of the time, my customer is reporting they are not getting the IP on cellular interfaces. So everything, if we check like signal level and other thing, that is showing normal. So in that case, how to proceed? What will be the best approach to tackle customer and how to push them back? Is it,
Okay.
yeah,
Okay, so if you see that everything is fine, your config is fine, your signal strength is fine, and everything else, it's in a TAD state and everything, and your ISP is also like everything, again, you have to go for DM logs because the DM logs are what will give you the best sort of picture as to which side is it, which is trying to like send the reject or which side is missing the packets. So the best way to proceed from there would be to actually take the DM logs.
okay. Because currently there is one case running with me only. In that, ISP confirmed that everything is fine and we are also getting the good signals. But when LT is fine now, we have replaced the LT card and other things, so LT is fine now. But customer is not getting the good Wi-Fi signal. They are getting only 1 point. So I have engaged wireless team for Wi-Fi part to check whether there is any problem with the Wi-Fi. So they were saying like they are not something their WLAN connection is not establishing. They said.
Okay, maybe there's also like a wireless module that's inserted there. They can take a look at it. But if you need just like sort of clarification on the cellular part, you can go ahead and collect the DM logs.
Okay. Okay. And I also find it very difficult to find out the IS image on Cisco portal. So can you guide me how to fetch the information? Because for routers it is very easier, but for these modules, I'm not sure how to.
See, so for what you do is go into Cisco interfaces and modules, go
Okay.
for LT wireless WAN interfaces, and here you'll have all the modems listed here. So 7430 for Telstra Japan or 7445, and you can directly download it from here.
Yeah, because for the routers we can directly search. So for this we
So
need
this
to.
is the path that you should ideally take. Cisco interfaces modules, LT wireless WAN interfaces, then select the modem that you have, and then go to that particular page.
All right. Thank you.
Welcome. The DM logs I was talking about, we have a text zone and an external page for that as well, where you have the step-by-step procedure of how to check, like how to configure the DM logs. Basically, this command is the only one that's mandatory. The rest just are additional commands where you see, okay, what is the file size that I want my DM logs to be at, and then what is the maximum size of the file, where do I want it to be. This is applying a filter. This is not generally used. And how to disable the DM logs once you've collected it, because you don't want to be running it forever, because you'll have repetitive files being collected. Then how to check if the DM logs have been created or not. And there's also an EM script, just in case you are not there to physically like run the DM logs again. So it's just a track that's tracking the cellular line. The moment the protocol goes down, which is the line goes down, then it will configure and collect the DM logs on its own. And also other commands. So you can refer this document as well. I'll be posting all these links in the ThinkSpace.
Okay. And there is one more case of mine, because most of the cases nowadays I'm getting only from WAN. So in that case, customer asked how to configure carrier aggregation on Sierra Wireless EM7430 PLTEA LA module. So I have researched so many documents, and in that it is just like saying this information is provided by ISP. We cannot configure it. We can support this, so I'm not sure about, because my customer is keep asking for the configuration guide, and I don't have the answer for the same.
What does he need the config guide for exactly?
Configuration guide for carrier aggregation on Sierra Wireless module EM7430P LTEA.
Okay. See, if it's just a module, so if it's a normal card, just verify if he needs it for iOS or iOS XE, and it mostly be for iOS. Just give him the config guide for LT. It's not like we have a separate guide for every modem. It would be the same. So carrier aggregation is currently deconfigured. However, I cannot find documentation on how to configure it. I will have to check this and get back to you. But if he just needs configuration assistance, you can just provide your normal config guides that we have, and